Hello friends, already we have discussed about the theoretical portion of the oscillator and the numericals in detail. Most of the part is already covered. Some parts like crystal oscillators, clamp oscillators, these things are there. But if you consider VIT University syllabus, then if you don't study those also, no problem, because crystal oscillator and clamp oscillator only fundamental idea is there in our course, not detailed explanation. But the numericals will come mostly from Hartley oscillator, Colpite oscillator, RC phase shift oscillator, or Winsbridge oscillator, Barkhausen criteria, and twisted questions based on those. Okay, so for the quiz component, this is my video on part 2 of MCQ on oscillator. Okay, part 1 you just check if you want to have a good preparation for your quiz part. So let us discuss some questions here, and this is going to be somewhat more interesting, and the level will be little bit higher compared to our previous MCQ part 1. So let us consider the first question, which is very easy, that in a particular oscillator circuit, if the value of the beta is 1 by 100, okay, beta is given as 1 by 100 and the minimum gain is required by the amplifier to get sustained oscillation is 10,000, 200, 100. What you know, see how to approach the part for the particular oscillator. The gain of the feedback network is given. You have to calculate the gain of the basic amplifier block. So obviously gain relation, you just recall Barkhausen first criteria, that is mod of A beta equal to 1, that is A equal to 1 by beta. So minimum gain of the basic amplifier will be 1 by 1 by 100, that will be basically 100. Okay, so answer is D. Okay, quickly you should perform this, because in quiz questions hardly 10 seconds you may get for one question. Now next question, this is going to be somewhat interesting, very interesting question. Frequency stability of RC oscillator is dash than LC oscillator. Options are greater, lower, same as, none. Okay, so before going to discuss this question, just I will show you a small simulation in MATLAB so that you can have one feeling on a particular topic. See, basically on what topic I have written the code, just I am giving an idea. Suppose one function y, okay, one function y is related with basic variable x as y equal to 1 by x. Okay, that is rectangular hyperbola, you all know, right? Another function y equal to 1 by root of r of x. Now you should try to understand, there are two functions, y equal to 1 by x and another one is y equal to 1 by root over x. Now you tell me, with varying the values of x, which function will vary rapidly? That you should understand. Suppose you change the value of x little bit, which function output or which y value will be going to change by a large amount for y equal to 1 by x case or y equal to 1 by root over x case, right? Obviously for y equal to 1 by root over x case, by changing the value of x little bit, y is going to be changed less compared to y equal to 1 by x. So basically in short, for y equal to 1 by x, the variation is going to be more compared to y equal to 1 by root over of x if we change x little bit. Okay, that's what you should understand. That means which is proportional to 1 by x, that will change rapidly compared to which is proportional to 1 by root over of x. Okay, so that's what I have written the code just to visualize this concept. See, simple lines, x equal to 0 colon 0.001 colon 6, that is from 0 to 6 with increment of 0.001. Why I have kept the increment very small? Because I want to plot continuous signal. These basics you know from the MATLAB basic concepts, right? Now y equal to 1 dot by x. Why dot by I have to give? Because x is array. Okay, so divide you have to give element by element division, you have to give dot by, then plot, then hold on, then y equal to 1 by square root of x, again dot by, then axis comment, grid on, and legend I have applied. I will show you why I have used legend. Now control A, evaluate selection. See, this is the graph which we are getting. See here, due to application of the legend command, we are getting the levels here. The red graph is corresponding to y equal to 1 by x and the green graph is corresponding to y equal to 1 by square root over of x. Okay, now see here in the x-axis, x value is changing from 0 to 6 with increment of 0.001 and the y-axis is change of y value, right? Now see, you just consider the two curves. See, suppose you go from x equal to 1 to x equal to 2. So see these two graphs, y equal to square root of x, basically the green color curve, and y equal to 1 by x is basically the red color curve. See, when x is increasing, the red color graph is changing rapidly, or y value is changing more compared to y equal to 1 by square root of x curve, right? Now again you consider the left hand condition, left hand position of x equal to 1. Suppose x changes from 1 to 0. See, the green color curve goes or changes comparatively in lower rate compared to the red color curve. Red color curve is basically y equal to 1 by x, and see it is changing very rapidly with increment or decrement on values of x. That means whenever x is changing, y equal to 1 by x, rate of change of y equal to 1 by x is more compared to rate of change of y equal to 1 by root over of x. That's what I want to show you. Now this is related with oscillator. How this is going to relate, that is very interesting. Okay, so you got the idea. Now see here, so in solving this question it is going to be very helpful. So the question is, frequency stability of RC oscillator is dash than LC oscillator, greater, lower, same as, none. You just recall the formulas of frequency of oscillation for the LC oscillator and RC oscillator, whatever I have discussed till now. So first comes, yes, Hartley oscillator. F is equal to 1 by 2 pi root over of L into CEQ, where LEQ is equal to L1 plus L2 when mutual inductance is 0, or if there is mutual inductance, then it will be LEQ will be L1 plus L2 plus 2M. Next, suppose you consider Colpit oscillator, then it will be F is equal to 1 by 2 pi root over of L into CEQ, where CEQ is equal to C1 C2 by C1 plus C2. Right? Next for RC phase shift oscillator, we know this is now becomes RC oscillator. For RC oscillator, the frequency of oscillation is equal to F is equal to 1 by 2 pi RC root over of 6, and for Wien's phase oscillator, F is equal to 1 by 2 pi RC. So see, one interesting observation you can come up in this slide, that is, for RC oscillator, F proportional to 1 by R. Okay, if C is constant, or F proportional to 1 by C when R is constant. But for LC oscillator, that is for the first two formulas, F proportional to 1 by root over of C, or F proportional to 1 by root over of L when other conditions are remain unchanged. So see, the variation of frequency in case of LC oscillator is proportional to square root over of C, or square root over of inductance value L. But for RC oscillator, it is proportional to 1 by X, like 1 by R or 1 by C. That means if R changes for RC oscillator, if R changes little bit or C changes little bit, then there is a huge change in frequency of oscillation. Just now I have shown, if there is a little change of X, for the curve Y equal to 1 by X, there is a huge variation. But if you observe for LC oscillator, suppose there is a small change in C, small change in L, the frequency of oscillation will not change by a large amount, because here the relation Y equal to 1 by square root over of X relation holds. And just now I have shown, if X changes little bit, for Y equal to 1 by square root over of X graph, the Y variation is less compared to Y is equal to 1 by X curve. Okay, that means what is the conclusion? Why I have shown you the MATLAB code? Because the conclusion is, from that and combining all this, we can conclude that as the frequency of oscillation for LC oscillator is proportional to 1 by root over of a factor, and in case of RC oscillator, it is proportional to 1 by the factor R or C, whatever. So basically, change in frequency of oscillation with change in R or C or L is going to be more in the RC oscillator compared to LC oscillator. So basically, if some electronic component changes due to some reason like due to change in temperature or moisture content, etc., see which circuit, which frequency of oscillation or which oscillator is going to affect more. The oscillator which is going to affect more is the RC oscillator, because with a small change there is a huge variation in frequency in case of RC oscillator, right? So frequency stability is less in case of RC oscillator compared to LC oscillator. So the answer will be the frequency stability of RC oscillator is lower than the LC oscillator. Okay, so I hope you have understood this concept. This is another very important concept and very important question for the quiz component related to analog electronic circuit paper. This is all for my this video. Don't forget to check the part 1 of the MCQ on oscillator, so that you will have a clear idea of what is the concepts which may ask in the quiz. That is one kind of suggestion you can say. This is all for my this video. Thank you for watching.